Hey, all you cool cats and kittens. Speaking of kittens, thought I would introduce you to Henry. I told you all about little Henry who was crying outside my window during fall break. So say hi, Henry. He's gotten a lot bigger since then. Like he might have doubled in size since then, but he wants to say hi to you. Say hi, but hello. Hi there. Yeah, he's still pretty tiny, but he's gotten a lot bigger since I found him. He and Jesse still aren't best friends, but they get along okay. I figured there he goes. Figured he would start trying to bite me a little bit. He doesn't bite very hard. He's just playing. He hasn't ever gotten mad or mean or anything. But all right, well there you go. There's Henry for you. Hello there. All right, let me pause this so I can throw him out in the hallway. Not throw. I'm not gonna throw him. Let me pause this so I can place him gently out in the hallway. All right, say bye. Okay, so I thought that I had hit resume recording. So I like recorded a bunch of stuff. So I guess it didn't get any of that. So anyways, we're going to be starting section 5 today, which is about periodic functions. I'm having deja vu right now. And we're not going to do a whole lot of this section, just kind of get an introduction to it, learn what a periodic function is, learn a couple things about them, and that'll be it. And I've got a small little assignment for you to do today. This homework assignment is due in class the next time you see me. This is not a homework assignment that's due on the day of the exam. This is kind of a special case. It's an e-learning assignment. So you do need to have this assignment finished when you come to class next time, and I am going to be collecting it and checking it for a grade. Okay, so make sure you do that. It's not very long. Shouldn't take you that long to do. Just make sure that you have it finished with you when you come to class next. Okay. Excuse me. It seems like it's been a while since we've done one of these e-learning day things. Okay, so last time when I went to share screen, it didn't focus. Let's see if it does this time. Cross your fingers, focus for me. Yes, not bad. Okay, so here we are in Unit 3, Section 5, Understand and Apply Properties of Periodic Functions. I'm not going to worry about these definitions up here, writing down definitions for these until a little bit later on today. I'm just going to kind of explain to you what a periodic function is, and then we'll come back and we'll put some legit definitions down. So at the bottom of this page, you have an example of a periodic function, which is simply just a function that repeats itself over and over again, it has multiple cycles of the function. And one thing that I want you to know is that even though this graph only goes to -5 and +5 on the x-axis, this function will continue to repeat itself indefinitely in both directions, meaning the domain is always going to be all real numbers, okay? So even though we're only seeing part of the graph, these graphs continue forever to the left and forever to the right. And you can kind of see how this is just like multiple cycles here. It just repeats itself in cycles. If you go to the library and you go to the periodical section, you're going to find newspapers and magazines and things like that that are released periodically, meaning every day or every week or every month, but they are released repeatedly over and over and over again. They're called periodicals. So these are periodic functions that repeat themselves over and over again. So yes, this is a periodic function. You can clearly see that it's repeating itself. And so we have this cycle of kind of y values that repeat: -1, -3, +3, -3, +3, and so on. As for the range here, we do the range the same way that we always do the range. The point with the lowest y value has a y coordinate of -3. The point with the highest y value has a y coordinate of +3. And so our range is -3 to 3. Notice the brackets there. Okay, for period and amplitude, that's going to be something that's kind of new. You might have studied waves in a science class, whether they were light waves or sound waves and things like that. And you might have talked about things like amplitude and frequency. So we've got amplitude here. Frequency and period are very similar. They're very related. They're not exactly the same, but they're very related. Honestly, I think period is a little bit easier to comprehend than frequency is. So when we talk about period, I'm asking you for an interval of x values that shows you how long it takes for that graph to repeat itself. So let me kind of highlight one period of this graph. So I could start at this point and go all the way up here and back down. And that would be one cycle of the graph. Now, honestly, there's multiple ways that you could highlight one cycle. I'll show you that in a minute. I'm just going to stick with this for now. So that's one cycle of the graph. And this is the thing that is just kind of copied and pasted over and over and over again. Now you can see that this cycle starts at an x value of -1, and the cycle ends with the point whose x value is 3. So this cycle occurs on the x-axis from -1 to 3, and the period is just the length of that interval. So from -1 to 3, that's a length of 4. If you want to, you can just subtract 3 minus -1, that's 3 plus 1, which gives you a period of 4. Now, like I was saying, there's different ways that you could begin and end a cycle. I began this cycle at kind of the bottom point. You could begin the cycle at one of the top points and then go all the way like that. And that would be one cycle from this point to this point, right? You could call that a cycle, but I want you to notice that the period is the same. If you drew the cycle that way, then the cycle started at an x value of -3 and it ended at an x value of 1. And so again, the length of that interval is still 4. 1 minus -3 is still 4. For the amplitude, amplitude is going to be a distance on the y-axis. And you might think that it's the distance from the lowest point to the highest point, and you're almost right. It's actually half of that distance. So I want you to think about where the midline is on this graph, which is this kind of line right here. It's the x-axis in this case. It won't always be the x-axis, but it is for this one. And you'll notice that if we start from that midline and go up 1, 2, 3, we're at the highest point on the graph. Similarly, if we start at the midline and go down 1, 2, 3, we're at the lowest point on the graph. So the amplitude is 3. In other words, it's half the distance from the bottom to the top. Okay, so if you go bottom to top, the amplitude is half of that distance. Okay, and all I want to do is just go through and look at these other examples of periodic functions. So here you can see this one is repeating itself over and over and over again. So yes, it's periodic. The domain is always all real numbers. The range, the lowest point has a y coordinate of -2. The highest point has a y value of +2. So there's my range. As for the period, you just need to kind of highlight one cycle. So that would be a little hump and a big hump. Or you could do big hump and then little hump, but that might be harder on the part of the graph that we're given here. Okay, so that's one cycle, a little hill and a big hill. That cycle starts at an x value of -2, and that cycle ends at a point whose x value is 4. From -2 to 4 is a length of 6, and so my period is 6. And again, 4 minus -2 is 6. As for the amplitude, again, the x-axis is the midline here, but the lowest point is -2, the highest point is at +2. That's a distance of 4, and half that distance is 2. So the amplitude is 2. On to the next one, we have another periodic function here, obviously repeating itself over and over and over again. Yes, that's periodic. Our domain is always all real numbers. Just making sure I'm recording. I feel like a YouTuber. I need to stop and make sure that my camera's still recording. Okay, for this one, the range, the lowest point has a y value of -2. The highest point has a y value of 4, so there's my range. For the period, you need to graph or just highlight one cycle of the graph. So you could go low point to low point, you could go high point to high point, however you want to do it, doesn't matter. By the way, this point right here is off a little bit, just when this thing got graphed. We missed the grid lines a little bit. So that point is supposed to be at an x value of 1. It's not. It doesn't look like it, but just trust me, it is. So there's one cycle of my graph. And that starts at a point whose x coordinate is 1, and that cycle ends at the point whose x coordinate is 4. So the distance from 1 to 4 is 3. And so my period is 3. As for the amplitude, on this one, the x-axis is not the midline of this graph. The midline is actually 1. If you want to figure out what that midline is and then count to the tallest point, that'll give you your amplitude. Like if my midline's 1, I go up 1, 2, 3, my amplitude is going to be 3. So if you want to do it that way, that's fine. But you might want to just go, okay, the lowest point has a y value of -2, the highest point has a y value of 4. From -2 to 4, that's a distance of 6, and then you want half of that distance, which would be 3, of course. Okay, in the next page here, we have an example of a graph that looks like it might be periodic, but it really is not. This one is not periodic. It's not periodic, even though it's going up, down, up, down, up, down, it's changing how far up and how far down it goes. See here, it goes up to a y value of 1, and then up to a y value of 3, and then up to a y value of 5. We don't have this pattern of y values that's repeating, and that's important, that the y value pattern has to repeat. And in this case, we do not have a repeating pattern of y values. The domain we can still do, it's all real numbers. This does continue on forever in both directions. Really, we should have arrows on these things, but for the range, this thing's just going to keep getting bigger and bigger and bigger and bigger, and so the range is all real numbers as well. We cannot do a period or an amplitude if the graph is not periodic, so you won't need to answer period and amplitude if it's not periodic. Okay, this is the last one we're going to do right here. This one is periodic. It goes up to the same y value at the maximum, down to the same y value at the minimum. So yes, this one is periodic. For the domain, it's all real numbers, as always. For the range, the point that's lowest on the y-axis has a y value of -3. The point that's highest on the y-axis has a y-coordinate of 3. So my range is -3 to 3. For the period, you need to just highlight one cycle of this graph. And notice, I want you to notice that, let me just highlight part of this here. This is not one cycle of this graph. I don't know what you call this shape, but this is just kind of the up version of the shape. We've got the down version here as well, and so we need to include that little down hump. Once I get to the end of this little down hump, then that's kind of the position I was in when I started the period. See how I started the period at a point that was just on the other side of the little small hill? And then I ended the period at a point that was just on the other side of the little small hill. So I've got, you know, a small hill on top and a small hill on bottom. That constitutes one period. There's other ways to draw that period there as well. You could go from the top of this little hill all the way to the top of this little hill. That would be a period as well. But the way I've got it, the period started at an x value of -3 and ended at a point whose x value is +3. That distance is 6. For amplitude, the lowest point has a y value of -3. The highest point has a y value of +3. From -3 to +3, that's a distance of 6. We want half of that distance, which gives me an amplitude of 3. Man, it seems like our amplitude is like always 3. No, there was once when it was 2. Okay, so now if we can go back to that first page, and I'm going to have you just get some definitions down here. We'll start with the definition of a periodic function. You might want to pause this if you need to get this down. But I said a periodic function is a function in which a specific pattern of y values repeats over a set interval of x values. So it takes that same period of x values to repeat that pattern in the y values. And hopefully going through and seeing some of those and talking about the pattern of y values helps you understand a little bit what I'm talking about here. If you need to pause that to write it down, that's great. For period, that is the length of the interval of x values, or on the x-axis, required to complete one cycle. And again, since we've seen some examples, hopefully that makes a little more sense to you now than it would have if I'd have just given you that definition in the very beginning. Okay, and finally for amplitude, that is half the distance between the largest and smallest y values. So there you go. Now, if you're going to go ahead and start on this homework assignment, which we're not quite ready for yet, but you can do some of it, it will ask you for things like what's the maximum value of the function. That's just the highest y value. It might ask you for the minimum value of the function. That's just the lowest y value. If it asks you for the range is that distance from the minimum y to the maximum y. I don't think it asks for anything else besides those. I don't have that assignment in front of me. I'm just doing it off the top of my head. But I think those might be some other things that are mentioned on that homework assignment that you might need to know about. Okay, I wish this thing would give me like a timer so I knew how long I had been going, but that's it. That's all I wanted to do. So now you can go and start that homework assignment. You can either print it off and do your work right on there, or you can do your work on your own paper. That's fine. Either way, I don't care. Just make sure your name's on it, your period's on it, and all that stuff. So hopefully that doesn't take you too long, and you can go on and get your work for your other classes done. So hopefully you have a great e-learning day, and make sure you like and comment and subscribe and hit the bell notification thing and all of that stuff. Is there something else I'm supposed to say? I need some catchy tagline to be out, right? Like PewDiePie does the bro fist. Yes, I know who PewDiePie is. I don't know if you guys do at this point. Is he still popular? Is he still a thing? I don't know. All right. So if you have any suggestions for my tagline at the end, maybe I'll try to turn the comments on for this video, and you can give me suggestions. Maybe we can have like a line for me to open my videos with, and then a line for me to close my videos with. Please remember that you need to keep any comments school appropriate. They can all be traced back to you. I'm not really like trying to threaten or anything. Just, be smart and use common sense. So I need an opening line and an ending line. If you have any comments, just let me know. Or if you just want to say hi to Henry, that's fine too. I'll convey your sentiment. Have a great day. Goodbye.